So they're giving us a complex number here and another complex number. Find the expression for Z1, Z2. So let's try and multiply them out. Given this in brackets, I think that may help. So I'll leave that in brackets at the moment and see if I can multiply it out like that. So we get here a 1 and a bi from Z1, and Z2 is a 1 subtract b squared and a negative 2bi, which gives us a 1 subtract b squared. And here it gives us a b to 1 subtract b squared I. This gives us a negative 2bi. This gives us a negative 2b squared I squared, which equals 2b squared. So Z1, Z2 is equal to 1 subtract b squared plus b times 1 subtract b squared I subtract 2bi plus 2b squared. So put all the real parts together, so we get 1 subtract b squared plus 2b squared plus in I is b into 1 subtract b squared I, not I after all, sorry, subtract 2b I. Let's look at part B, hence. So hence means I need to use this bit, argument of Z1, Z2 is pi over 4. So find Z1, Z2, and its argument is pi over 4. That means in an R-gram diagram, it's somewhere along here, where this is pi over 4. And if that's pi over 4, it's 45 degrees, which means there's my real part, and there's my imaginary part, and these lengths are the same. That is the same as that. So we know the real part of Z1, Z2 equals the imaginary part of Z1, Z2. So let's try that. Here's our real part here, and here's our imaginary part. So we get 1 subtract b squared plus 2b squared equals b into 1 subtract b squared subtract 2b. Let's take everything over to the same side to make it equal to 0. So let's try and make that equal to 0. 1 subtract b squared subtract b times 1 subtract b squared plus 2b squared plus 2b equals 0. Can we factorise that? Yes, we can. We get a 1 subtract b squared into a 1 subtract b, because here look, I have 1 subtract b squared, I have one of them, and 1 subtract b squared, I have negative b of them. And this one will factorise into plus 2b into b plus 1 equals 0. That's only 1 subtract b. Yes, so now 1 subtract b squared is 1 subtract b, 1 plus b, 1 subtract b, plus 2b into 1 plus b equals 0. And now I've got a common factor of 1 plus b. So we get 1 plus b into 1 subtract b squared plus 2b equals 0. So 1 plus b equals 0, or 1 plus b squared, that's 1, subtract 2b plus b squared plus 2b equals 0. So b equals negative 1, or b squared plus 1 equals 0. B squared equals negative 1. B equals square root of negative 1. No real solutions. Therefore, b equals negative 1 because b is real.